cs141. Are you pumped? Of course you are. Wait, how do I stop this? There we go. Okay, so now that you're sufficiently excited, cs141, lecture number 2, what's on store for today? Stuff about formatting, concatenation, variable types, arithmetic, what we call IPO programming, input, process that input, and then produce some output. And then the need for being able to handle input, which we actually currently can't do, but we'll learn how to do next week. So formatting. Style matters. Ugly programs are ugly, and they're hard to read. You would not submit an FP paper where, it was just like one 4-page long paragraph. You're not, who wrote that way? I guess Defoe wrote that way, Daniel Defoe, like Robinson Crusoe. You're not like a 18th century proto-novelist. You're going to break things up into paragraphs. You're going to break things up into sentences. You're going to use punctuation. You're going to write things in a style that somebody's going to be able to read. You're going to need to do the same thing with your programming. Now, the style is going to look a little bit different. The rules are going to be a little bit different. But the style is going to be very important for you to be able to read it and for other people that you might be working with to be able to read your code. So some important notes about style. Not so much style, but this is actually just correctness. Open bracket in Java means begin, and a closed bracket means end. And you need brackets to surround everything. So you need brackets in your program around the main method. You need brackets around the entire program. You basically need brackets to begin and end each important subsection of your program. They're sort of like, I don't know, you can think of them as like the beginning and ending of a paragraph or something like that, like where you would indent. Other things to note are white space. There's some places where a white space is necessary, like for example between the word public and class at the beginning of your file where you have public class. You have to have a space in between public and class. If you didn't have that space, it would look like a single word and we couldn't process it. And so whenever a white space is required, you have to have one or more. You can have as many as you want. You could have 10 spaces, you could have enter keys, you can use tabs, you can use any kind of a white space character, but if one's required, you have to have at least one. Now there's situations where you can have 0 or more, like for example between the plus in 2+2. And you'll eventually develop good instincts about where spaces are needed and where spaces aren't. Eventually you won't even really think about this. So BlueJ actually will help you with this formatting, with your brackets, with your indentation, with your spacing. Don't fight the editor, let the editor help you. So let's look at some examples of how we can actually do that. So here's just a sample program. We've got this little hello thing going on. So here's what I'm talking about with the brackets. You got your open bracket, your closed bracket. You've got public class hello. Remember, hello is the name of the program. Public class, this is part of the magic incantation, the expecto patronum. For you Harry Potter fans out there, it's the magic words. We got the open bracket, the closed bracket. If you put your cursor here, you'll notice it's highlighting the corresponding open bracket. Similarly, if you put your cursor here, it's going to highlight the corresponding closed bracket. Unfortunately, if you put your cursor there at the beginning of the open bracket, it doesn't actually do anything, so that's kind of unfortunate. Similarly over here, same thing here. You can sort of see how these things match up. Now, for a simple example like this, it's pretty clear what's going on. There's 2 sets of brackets. This stuff is all nested inside of this bracket, not a big deal. For more complicated programs, you're going to have multiple stages of brackets with a lot of nesting going on, and so in that situation, you have to be very careful, and this ability to track the brackets is actually really helpful. You'll also notice there's indentation, so public class hello in this open bracket, these are kind of at the beginning. Then we've got main has been indented, then the stuff inside main's been indented. If there were more stuff in main, like as we'll learn shortly, a loop or an if statement or something, that would have more indentation in here. We just sort of keep indenting. The indentation visually tells you, okay, inside public class hello, we've got this, main, inside main, we've got this. If there are more stuff in main, that would also be indented. You can visually see who owns what. You know, main is owned by hello, it's nested inside hello, and so on. So that's just some stuff to think about. Now, when you need to add a new line, the easiest way to do that is to put the cursor at the end of a previous line and hit the Enter key. Now note what happens. It automatically goes to the next line and indents it for you. Now, if you were to just sort of like, I don't know, go down here and hit Enter and then go up here, things aren't really in the right place. The easiest way to do this, go to the end of the line, hit Enter. It's going to automatically indent it to the right place for you. Don't fight the editor. The editor is designed to help you make this process easy. So go ahead and take advantage of that. Now we start typing things out, system.out.println, you know, indentation is awesome. And note here, we haven't closed that quote yet. As soon as we close the quote, notice to highlight everything in green. We put our parenthesis. Notice it's doing the same thing. It's showing us where the matching parenthesis is. Go ahead and put our semicolon. And then if we want to check if this is correct, we can go up here and click compile. And as we can see, everything's fine. Now, what do we do when sometimes you get your indentation screwed up? So like for, you know, maybe even though you kind of know you're not supposed to have it look this way, suppose your code looks like this. And you're like, oh crap, you know, for some reason this didn't get indented. Well, one way to fix it is to go to the beginning of the line and start hitting spaces. But that's annoying. Easier way to do it is go to the first line that you think is wrong and hit Tab. And it'll indent it to where it thinks it needs to be. So if there's just one or two lines that are in the wrong place, go to the beginning of the line, hit Tab. BlueJ will then indent it to where it thinks it's supposed to go. In the BlueJ editor, the Tab key does not mean Tab key. It means try to indent this to where you think it's supposed to go. So that's pretty useful. Now, suppose you have... Now, tabbing is great if you have like one or two lines that are in the wrong place. So suppose, I don't know, we have something that looks like this. It's like the indentation's all screwed up. I look at this visually, I can't tell what the heck is going on. BlueJ will auto-indent this for you. If you go up here to... I actually need to move the hidden screen recording thing. Under... Oh, that's QuickTime, sorry. Here we go, BlueJ. If you go down here under Edit to Auto Layout, bam! It tries to fix the indentation. Now, if you suppose you're missing, I don't know, like maybe this open bracket is missing, and we go up here to Auto Layout, and it jumps the indentation, everything looks crazy. Usually that means there's a bracket missing. We can go ahead and put this bracket back in, do an Auto Layout again, bam, it's going to fix everything. So you should be remembering, use the Enter key from the end of a line to go down. That tells you where to start typing. Use the Tab key. You know, if somehow you end up on a line, but, you know, you're not in the right place, hit Tab. It'll try to jump you to the right place. It's not perfect about it, but it's going to try. And remember, you should be using the Auto Layout feature to fix everything. There's all these tools at your disposal to help you with your style to make your code look readable. If you're not taking advantage of those tools, I don't know what to tell you, but if you sort of like come to me or to one of the TAs for help, and your code sort of looks terrible, we're probably going to look at it and go, ah, oh, my eyes, please hit Auto Layout. And then we'll kind of like look away until you hit Auto Layout, and then we can kind of look at it and see how it looks. So if you don't want to hear me make those like odd sounds and go, ah, my eyes, you probably want to remember to use your Auto Layout function. So let's see if I covered everything. Enter strategically, using BlueJ to max braces, Tab to fix one or two lines, and the Auto Indent or Auto Layout. Great. Covered everything. Okay, let's talk about variables. So a variable is a container for data. We need some place to store values while we perform some computations on them. If we couldn't really store values with a programming language, it would actually be very difficult to do much computation. So these variables are actually going to be quite important, and after a while, they'll just be second nature to you. So Java is what we would call a strongly typed language. This is just a term that, if you have no context in programming languages, doesn't make sense. But just for the purposes of completeness, strongly typed, this means that you have to specifically declare the type of each variable that you create. So we're going to start with three types. We're going to have int. These are for integers, like 4 or 17. Double. This is for double precision floating point numbers, also known as decimals like 6.2, and string, which we've kind of already seen, though we haven't seen them in the form of variables. This is to store strings of printable characters, spaces, digits, 7, punctuation, etc. Now you should note that the type int and double start with a lowercase, the type string starts with an uppercase. Java is a case-sensitive language. The capitalization of types and variable names and function names and things like that, it matters. It's very important. So you have to keep it in your mind to pay attention to the case. So let's talk a little bit about int. It's our most basic data type. Ints can store any integer. Well, not any integer. It'll give you values from about -2 billion up through about 2 billion. The reason you get this range of about 4 billion values is you have 32 bits to store this in. And if you do your powers of 2, 2 to the 32 gives you a total of about 4 billion. It's about 4 gigabytes of total possible values. So if you need numbers bigger than that, there's another type called long. These are up to 64 bits, which is just absolutely ginormous. We're not going to use anything bigger than int in cs141, so you don't really have to worry about the larger integer types, but it's good to know that they're there. Doubled is going to store decimal numbers, so double short for a double precision floating point number, as opposed to a single precision floating point number. Oh my gosh, I'm going to sneeze in the middle of this video. Nope, I didn't sneeze. Now, floating point basically means scientific notation because the decimal point floats around. If you think about, like 10.23 times 10 to the 7th power, actually it wouldn't be 10.23, it would be 1.23 times 10 to the 7th power, and you would then use that 7th power to sort of float that decimal point around. It's kind of the same thing. Do you need to know any of this? No. For your purposes, integers, whole numbers, or negative numbers, -4, 7, 0, 53, 287,612, doubles, 4.1, 6.0, 3.2, etc. And strings are first strings of characters. Note the capitalization. So, some code. Of course, we have some comments to include what we're talking about. A little explanation for the programmer. We have int x. This declares a new integer variable named x. And x equals 7 assigns the value 7 into this little container x. So we can do it in 2 lines. You can actually do it in 1 line, both create the variable and give it this initial value of 7. So you can do it this way, you can do it this way. Java's not going to care. It's going to treat them both exactly the same way. Double, similarly, we could say, double D is equal to 6.7. We can do it in 1 line, we can do it in 2 lines, however. Doubles can also convert ints to double. So we could say double D equals 6. And this will do what's called a type promotion. It'll take 6, which doesn't have any decimal part, and it'll add the decimal part to it. It'll convert it to 6.0. Those conversions are always okay. The reverse, to go from an integer to to go from a double to an integer, is never okay without explicit instruction from the programmer, which we will see. So, mixing doubles and ints, should this work? Go on to Moodle, try this out. Is this going to work? Yes, no, or, I have no idea. If you go on to Moodle, you'll only have choices for yes or no. So you got to commit and pick one. And go ahead and pause me. When you're done, come back. Did you say no? If so, you're correct. This won't work because 6.7 is not an int, and there's no way to make 6.7 into an int without throwing away information. 6.7, there's just no way to make that int. You'd have to get rid of the 0.7. You have to either round it up or round it down. You're losing precision, and Java's not going to allow that. Let's try another one of these. Should this work? Int x equals 6.0. Yes or no? Go ahead and answer this on Moodle and come back. If you said no, then you're correct. This also won't work. Now, you and I are smart. We can look at this and say, well, 6.0, that's a double. But it's sort of very close to 6. In fact, it's exactly 6 with some decimal stuff. We should be able to convert this, right? No, in practice you can't. Java is very strict about this. no doubles will be converted to integers without an explicit instruction from the programmer saying it's okay. This is actually to catch errors. If you're allowed to sort of freely switch between types and throw away information, you can end up taking 6.7, converting it into integer, now it's 6, convert it back to a double, becomes 6.0, you've lost that 0.7, there's no way to get it back. What will this print? Just want to see if you can guess. We haven't actually seen the syntax yet, but see if you go ahead and take a shot at what you think this will print. If you said 6, you're correct. This is an explicit cast. It's saying, okay, Java, I realize this is a double and this is an int, and those aren't compatible, but I'm sticking in the type I would like you to convert or coerce this into, and I'm explicitly saying it's okay. I'm the programmer, I'm the human here, I'm in charge, change this type. Java will change it, and it'll do what's called a truncate. It'll actually round down. There are functions you can use, which, maybe we'll learn later, where you can tell Java to go ahead and round up or round down, like a round function. But by default, if you do an integer cast, it's always going to truncate down to 6.0. Even if it's like 6.999, it's just going to cut it down to 6. Let's do one more. Double D equal 8 divided by 10. Then we print out D. What is this going to print? Go ahead and try this out on the Moodle. If you came up with 0, you're correct. This is what's called integer division. This is intuitive to computer science people and not intuitive to really anybody else, some mathematicians or philosophers or something like that. Maybe, but most people are like, well, 8 divided by 10 is 0.8. Well, that's true if 8 and 10 are doubles, but 8 and 10 are both integers. So what Java's going to do, well, 8 divided by 10, well, 10 goes into 8 0 times, and since these are both integer inputs, the output has to be an integer, so the output there is just 0. Now I'm taking that 0 and assigning it to a double, so I could go ahead and, coerce it to 0.0. That would be fine. And so we're going to come up with 0. 0 is the same as 0.0, so I mean it technically might print 0.0, but it means the same thing. It's going to be 0. Even though we're assigning it into a double, this division operation takes place first, and both of the inputs are integers. So keep this in mind. This does not make sense to really anybody else other than people who have done a lot of programming who are used to this integer division. Kind of a pain, but you gotta understand it because your instinct is going to be 8 divided by 10 is 0.8. Of course it's not, it's 0. How could we get 0.8 if we wanted to? So try this one out in the Moodle. Which of these is going to give us 0.8? It's actually all of the above. So obviously 8.0 divided by 10.0, 8.0 is a double, 10.0 is a double, so that's going to give us 0.8. But it turns out 8.0 divided by 10 and 8 divided by 10.0, these both mean the same thing because Java can always take integers and promote them to doubles. So it sees 8.0, it's like, well, that's a double. I'm trying to divide it by an int. I can't divide doubles and ints, but I can take this integer and convert it to a double. So it'll do that, come up with 0.8. Same thing down here. I mean, there's another way we could do this. We could just say double D equal 0.8 if we really want 0.8, but that's not the point of the exercise. What we're trying to figure out is how division actually works in Java, and this is what we need to understand. That all three of these mean the same thing. So it's actually all of the above. Now, string variables, well, these string variables, they can actually save you from retyping a message in a print statement. They work for a number of useful things as well. And these string variables are going to work about how you'd expect. You create your type, so like string, we're going to name it S1, and we're going to assign it the string, this is a string. So we're assigning a string literal on the right-hand side to a string variable on the left-hand side. Then we can print out S1, and maybe we could say, like S1 concatenated with and then S1 again. And so here we wanted to say this is a string and this is a string. We don't want to type it twice. We can just sort of use this variable. So string variables work about how you'd expect. One thing to remember, this S has to be capitalized. If you don't capitalize the S, the code's not actually going to work. It won't even compile. And so let's actually see an example. Oops, that's not the example we want. Nope, that's not it either. Where the heck did I put it? Project, open recent. Oh, that's good. I lost it. Nope. 141. Boy, so how's the weather? Where in the heck did I put it? In class, it should be called sample 1. Ha! Great. Okay. And so what I wanted to do, this was the example we had seen a little bit earlier. You know, suppose we were here, we're like, hey, guess what? I've got some string s1, and I assign this, you know, hello world. Now I want to, like, say, okay, check out this message. We're going to concatenate in s1. I compile this. It works. I can run it. It'll do basically what you'd expect, right? So life is good there. If I don't capitalize this and I try to compile it, I'm hitting Control K, by the way, on Windows and Apple K on a Mac. If I do that, bam, it's going to say cannot find symbol class string. Now, when that happens, that usually means it's a capitalization issue with a type like string or something like that. So, you know, if we go ahead and change that, it'll go ahead and work. Other exciting errors, if you leave out a semicolon, it'll pretty much tell you a semicolon's expected. If you leave out brackets, much crazier things happen. Reached end of file while parsing. That almost always means you're missing one of your closing braces. If you're missing an open brace, oh, it actually caught that. Brace expected. What about here? Ah, yeah, here we go. It's saying semicolon expected. Semicolon's not really expected. If you get semicolon expected with like a line that's the first, you know, like this is called the method header, method declaration, usually that means you're missing this open curly brace. So just some things about compiler errors to keep in mind. Let's see what else we've got. Oh, great. Input, process, output programming. This IPO part stands for input, process, output. We don't actually know how to handle input yet, but we'll learn that soon. And we know how to handle processing and output. So moving on, let's suppose we want to do a Fahrenheit to Celsius converter because we don't have Google or the internet or a calculator or anything else in the world other than a Java program that we're about to write. But we do of course have a computer. We just don't have like anything else. So what's the formula to go from Fahrenheit to Celsius? Well, we know Celsius is 5/9 times Fahrenheit minus 32, and Fahrenheit is 9/5 times Celsius plus 32. Now, of course, remember, these are algebraically. Remember, 5 divided by 9 in Java is, of course, 0, and 9 divided by 5 is 1. So we're actually going to need to do some work to actually get the values that we're looking for converted into doubles properly. So here's the assumption. So assume we have a Fahrenheit temperature in a variable. Let's call it ftemp for Fahrenheit temperature. We want to convert this to Celsius. We're going to put the result in a variable named ctemp for Celsius temperature, and then print it. So some of the questions you have to be thinking about, knowing you need to do this, well, what type should ftemp be? What type should ctemp be? You want to make sure you're using concatenation in the printing, and you got to be aware of integer division. More or less, it'll look something like this. So I'll say, like, well, double ftemp is 75.0, maybe it's 75 degrees. To convert this to ctemp, 5.0 divided by 9 times the ftemp minus 32. And all your regular order of operations rules that you learned in math are still going to apply. So division and multiplication have a higher precedence than addition and subtraction. Parentheses has the highest precedence of all. There's actually some other things that have a higher precedence than parentheses, like exponents and the unary minus sign. So like if you have like -7, that negative has a higher precedence than parentheses. But the basic rules of operator precedence that you learned in algebra are still going to apply. So this is what we could go ahead and do. And we don't have any way to get input. Right now we're just kind of sticking a number in here, but eventually we're going to learn how to get input. And so what can't we do yet that seems important? Input. We have no way to read inputs from the user. There's something called a scanner, which we'll learn shortly, not today, but in a future lecture, but very soon, that's going to help us with that. We'll cover this soon. So that's what we've got. Cool. Well, thanks for listening.